In this video, I'd like to talk about the math question of the day from March 21st, 2023. And we need to solve the equation, this quadratic equation for the variable x. Now, this is something that is typically taught in an Algebra 1 class, usually towards the end of that class. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And if you do have suggestions for future questions of the day, feel free to leave those as a comment. So I'll start with just rewriting everything. 25x squared minus 20x, this is equal to -4. We have a quadratic equation, a polynomial of degree 2, since our highest power of x is 2. And with these types of equations, it's usually best to set one side of the equation equal to 0. And from there are many different methods to actually solve it. So let's start by just adding 4 on each side of the equation so that we have 25x squared minus 20x plus 4. And now this is equal to 0. And from here, we have, like I mentioned, a few different options. One is that we can just use the quadratic formula. And just to remind you, if we have some general quadratic, ax squared plus bx plus c, where a, b, and c can be any real number, then when you solve this for x, when you complete the square in this very general form, then you can find that x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by twice a. So if we can figure out what a, b, and c are, we just plug those into our formula and we can figure out these solutions for x. And usually we will get two solutions. We will have the case where we add this square root term and the case where we subtract this. But there sometimes is a special scenario where the square root term is equal to 0, or we say the discriminant, this b squared minus 4ac, is equal to 0. And in that case, we would only end up with one solution, though we typically think of it as a double solution. It's the same solution twice. But going back to our problem here, we can use this, or we could try to factor this. We could try to factor this into two binomials that are multiplied together and then use the zero product property to actually solve for x here. However, this method can be fairly difficult because the coefficient on x squared is not 1. If it's 1, then this is not too bad. But if it's not 1, then you'll have to use the grouping method, or you can use guess and check, though that would be quite tedious. And I also do want to mention that factoring these quadratics most of the time does not work. This is actually factorable, but if any of these numbers were changed just a little bit, if this was a 3, a 5, a 6, a 7, then this would no longer be factorable. And that's just changing the constant. If the coefficient on x or x squared were changed by even a small amount, then in all likelihood it wouldn't factor. So factoring only works in special scenarios, but it works enough that it's worth learning the techniques. So when answering this, let's first use the grouping method. We'll factor this and come up with our answers there, but we can also look at using the quadratic formula very quickly at the end of this. So let's start by using the grouping method to factor this. And the general idea is that we're going to take this middle term and split it up into two terms. And once we split this up into, let's say, dx plus ex, then we'll have four terms. We pair first two together, then we pair the second two together. We factor out the greatest common factor from each, and from there we can use the grouping method and factor further to turn this into a product of binomials. But let's go through this slowly. We need to break this term up into two different terms. And it can't just be any two terms. It has to follow a specific pattern. And for this, I usually draw a cross. We know that they have to recombine to this -20x. So they have to add up to -20. This is the adding part. but they have to multiply to the product of a and c. Whatever the coefficient on x squared is, multiplied by the constant term. And 25 times 4, that is 100. Now, the intuition behind why we multiply those together, I will admit, is a bit difficult to understand. So I won't try to convince you why this is true, but it is something you can assume is true. So we're looking for two numbers that add to negative 20 and multiply to 100. And you might notice that negative 10 and negative 10 would satisfy those conditions. So we can rewrite this as 25x squared minus 10x plus 4. And we didn't change the equation, since if we combine like terms, we just get back where we started. Now at this point, we want to group the first ones and the second ones together and pull out the greatest common factor from each. We can pull out a 5x from these, so that we're left with a 5x here and a minus 2 here. And let's pull out this negative so that the coefficient on x is positive, like we have in here. And it looks like we can divide both of these by 2. So negative 2 is the greatest common factor here. We would have 5x left here, and 4 divided by negative 2 is just negative 2. And notice that we ended up with the same expression in parentheses for both of these terms here. And if that wasn't the case, either a mistake was made or it's not possible to factor this by grouping. So this method only works if these end up being the same expression. Since at this point we can factor 5x minus 2 out from each of these two terms. We get 5x minus 2 pulled out. Here we're left with 5x, and here we're left with minus 2. And this is a special case. We have this 5x minus 2 squared is equal to 0. But we can use the zero product property. If either of these factors is equal to 0, then we would have 0 multiplied by something, but 0 times anything is 0. And to figure out which x value makes this 0, we can just say 5x minus 2 is 0. Add 2 to the other side, divide by 5, and you'll find that x is 5/2. But this value actually works in the other expression as well. So this is the rare case with a quadratic equation where we end up with one solution, but we would consider this a double solution. We essentially have the same solution twice. And it does have interesting graphical properties when we end up with this double solution. So we found that answer through the grouping method, but we can also look at it by using the quadratic formula. Let me just make a bit of space for that. We'll still need a, b, and c, but we can plug those in now. We have that x is the opposite of b, so it'd be positive 20, plus or minus b squared, so minus 20 squared minus 4, multiplied by a, which is 25, multiplied by c, which is 4. All of this divided by twice a, which would be 50. And we just need to simplify this expression here. And I do want to mention, I noticed a mistake with the answer. It actually should be the reciprocal of this, since you add 2 and then divide by 5. So it should be 2/5. But this mistake just highlights the need for checking your work. This is why it's so important, since even if you've been working on math for decades, you are still human and you still make mistakes. We are not computers. So you need to come up with methods for checking your work, and using two different methods, two different approaches to solve some type of equation is a great way to check. Since if both methods end up at the same answer, then you can feel relatively confident that you did it correctly. And at this point, simplifying this, we would have 20 plus or minus the square root of minus 20 squared, which is 400. And 4 times 25 is 100, times by 4, that's also 400. So this square root will become 0. And we just get 20 plus or minus 0 over 50. And of course, adding or subtracting 0 won't affect anything. We get 20 over 50, which simplifies to 2 over 5, which is the exact same answer that we found when using the grouping method of factoring.